Alright, welcome back. In this lesson we're going to discuss some ways we can use this new wildcard index in MongoDB. We're going to cover two examples. The first involves any collection with an unpredictable query shape, and the other affects the way that we would implement the attribute pattern in our data model. Collections with an arbitrary query shape are good candidates for the wildcard index. Arbitrary query patterns become more common as data becomes richer and more abundant, especially in a database like MongoDB that encourages very large documents. And because we can use data in every facet of our business, we don't always know how a dataset will be used when we create it. In this example, we have a collection of loan data where we store information about the loan with a subdocument describing information about the borrower. Let's say that our department wants to learn more about the types of borrowers we have. We know that our queries will be run against the borrower subdocument, but we don't know exactly which fields will be most important to us because we just started exploring the data. So to enable this sort of open-ended data exploration, we can create a wildcard index on every field in the borrower subdocument. We create the index with the createIndex command, but instead of a regular field here, we use this notation to denote all the subpaths of the borrower subdocument. Then when we query on age or any other field in the borrower subdocument, we know that this query will be supported by at least a single field index. This wildcard index can also be used to simplify our implementation of the attribute pattern. For those who are not familiar, the attribute pattern is a data modeling strategy that we can use to index and query across an arbitrary number of attributes. In this example, the attributes are the number of streams that a song received on different streaming platforms. We've taken all the top-level fields describing these different counts and put them all in subdocuments in the same array. This way, we don't need to query across these different fields. We can just query on streams.k or streams.v. Similarly, we could create a compound index on streams.k and streams.v, and all new subdocuments in the streams array that contain a k or a v will result in a new index key being created. But if we use a wildcard index on the streams field, which looks like streams.$**, then we can use an object here instead of an array of subdocuments, and we can assume that every field in this subdocument will be indexed. In this example, we didn't need to use an array of subdocuments for these key-value pairs and give them all a particular name like k and v. We just create an index on all the subpaths in the stream subdocument, and then we can query on any of those subfields knowing that they'll be supported by an index. So in this lesson, we discussed two important use cases for the wildcard index. The first was a collection where we don't know the exact queries, which the wildcard index mitigates by creating a single field index on every field in a document or subdocument. The second was simplifying our implementation of the attribute pattern in our data by using a wildcard index on the subdocument containing our attributes.